All right, here we want to look at one of the practice example tests to get ready for our derivative mastery test, where we just prove that we know how to do the mechanics of derivatives. So power rule, product rule, chain rule, and kind of mixing them all together. So number one is take the derivative of 5x to the third plus square root of x plus 1 over 2x to the fourth minus x squared plus 31x plus pi. All right, so very first thing, if something isn't already written in terms of a power, it makes it way easier to do power rule if we rewrite it. So x, square root of x is the same as x to the 1/2. X to the fourth in the denominator is the same as x to the -4. Be careful that doesn't change the front number. This is still 1/2 times 1 over x to the fourth. And everything else looks pretty ready to go. And so now I can take the derivative of everything. So 5x to the third is 15x squared. X to the 1/2 is 1/2 x to the -1/2. So don't forget we're subtracting 1 off the exponent. When I multiply this out front, -4 times 1/2 is -2. And since we're subtracting 1, it'll be to the -5th. Derivative of -x squared is -2x. Derivative of 31x to the first is 31. X to the 0, so 31 times 1. And pi, don't forget, is a constant, so derivative of a constant is 0. And so we're essentially done, but we don't want to leave like negative exponents. You can put this as 1 over 2x to the 1/2, or you can put it back to square root. Either one is fine. The negative means it's in the denominator. And these ones are about as cleaned up as they're going to be. So number one, this would be a great simplified answer. All right, let's look at the next one. X squared times 2x minus 3 to the third. So we might notice this part is chain rule, but before we get to that, don't forget there's something multiplied by something else. Sometimes that's easy to overlook. So here's my first multiple, my second multiple. So here's my f. And the derivative of f is just 2x, derivative of x squared. And then my g, the second thing that's multiplied. And notice this one, the derivative takes chain rule because it's 2x minus 3 inside of something to the third. So this is 3 something squared times the derivative of the inside. Derivative of 2x is 2. Derivative of -3 is 0. So derivative of the outside times derivative of the inside. And maybe I can get my coefficients together real quick. And so now product rule, first times derivative of the second, although the order doesn't really matter because it's addition. So my 6x squared, 2x minus 3 squared, plus 2x times my original second half, so f prime g. So there's a nice product chain rule derivative. All right, next problem looks like quotient rule. So I have my high and my low piece, or sometimes you can still write them as f and g and still think of it as high and low when you're trying to remind yourself which one goes first. Totally up to you. All right, so the derivative of the bottom is 2x. And the derivative of the top is 3x squared minus 2. And so then all I really need to remember for quotient rule is what order everything goes in. So low d high minus high d low. Over the denominator square we go. Low d high minus high d low. So low d high. This part will be first. So low d high minus high d low. This one times this one. And it's multiplication, so you can write them in any order. Sometimes if you have a single term, it just looks better to have it out front. And then over the denominator square we go. So over the denominator squared. So x squared minus 5 all squared. And like we said for the derivative mastery test, or depending what you're doing with the problem in general, the question is just take the derivative. So once you have the derivative, you're done. There's no need to like FOIL or distribute or get like terms together. You can just leave it after you're done with the derivative. All right, here is a fun one. Use a different variable just to see if we're paying attention. So we're doing t instead of x, but it's all consistent. It's saying take the derivative with respect to t. There's no implicit or anything on this one. And to the 5th power. All right, so if we notice, we have chain rule because it's something to the 5th, and then the whole fraction is on the inside. So when we start doing our derivative of the outside, it's going to be 5 something to the 4th. And you can write it down now or you can write it down later, but when you do the derivative of the outside, you don't touch the inside, right? So there's our derivative of the outside. And now we have to do times the derivative of the inside. I'm going to leave a little space and then I'm going to go away from this and write down the inside just so we don't kind of lose the forest for the trees. So the inside on this one is 4e to the t over 3t plus 1. So ddt, or you could use this little dash notation, whichever one you like. So we're trying to take the derivative of this. Notice that uses quotient rule. So we want the top is 4e to the t. Good news, the derivative of e to the x, or e to the t, is just e to the t. So just 4e to the t. And the bottom is 3t plus 1. And the derivative of the bottom is just 3. And so now we'll put our pieces together. We have like low d high. So here's low d high. So 3t plus 1 times 4e to the t minus high d low. So this one times this one. So 12e to the t, 3 times 4 we can get together. And then over the original bottom squared, low squared. All right, so here's where I went and did this off on the side. So we didn't want to lose the forest for the trees. So our whole goal was to take the derivative of the inside, which required quotient rule. Now that we have the derivative of the inside, I can just go plunk it in here. Doesn't matter what order you write this in, but it maybe saves me a little space to put it first. And then once again on derivative mastery test, the goal is to take the derivative. You don't have to do a bunch of simplifying. I just want to see that you can take the derivative. So this is a perfectly fine answer. Derivative of the outside times derivative of the inside, and the inside required quotient rule. And if you got that one, this one should be easy. Just a normal old chain rule one. So 2u to the 5th minus u all to the 11th power. So I recognize it looks like this is the inside and the something to the 11th is the outside. So derivative of 11, something to the 11th, is 11 something to the 10th. I don't touch the inside on that one. And then I do times derivative of the inside, which is 10u to the 4th minus 1, since that was 1u. So there's my answer for number 5. All right. Number 6, if you're creative a little bit, or if you notice it, basically, you can save yourself a little time on number 6. Technically, if you did quotient rule, it would work, but it's not necessary in this. There's not a variable up top. You could also just from the beginning notice this is the same thing as 4 minus 2x to the negative 3, meaning it's in the denominator. And so that turns it into a slightly quicker chain rule problem. We have something to the negative 3, so derivative of the outside is negative 3, something to the negative 4, careful about the minus 1 thing. And then the derivative of the inside is minus 2. And so then negative means it's in the denominator. Be careful, the negative 3 times negative 2 ends up on the top. So we have 6 over 4 minus 2x to the 4th. So there's the derivative of that 1 over fraction we started with. All right, number 7 goes back to just taking the derivative of individual terms. So the first thing I want to do is rewrite it. Way easier to see power rule if you have them all written as something to a power. So that in the denominator means that it's negative 7, or it just helps avoid sign errors, which is the main thing that probably happens on a problem like this. So I rewrite them all as negative exponents. And so now I can take the derivative. So this is negative 28, right? Negative 7 times 4, x to the negative 8. Negative times a negative is positive 6, x to the negative 3. And then this is negative 1, x to the negative 2. And so we're done. We could maybe make it look a little bit nicer by putting our negative exponents back on the denominator, since a negative exponent means the reciprocal. And you can put plus negative 1, or you can put your minus here. It doesn't make a difference. Sometimes I like to put it up top. It just makes it, emphasizes it more so it doesn't blend into the rest of the problem. Totally up to you. This and this